we have user interface and microservices ready. In this video, we will add the MongoDB database to the project. Currently we have hard-coded the response JSON in Express microservice. In real scenarios, we must be storing all the data in database tables. Microservice will be fetching data from database and creating JSON object. And finally UI will receive this JSON object and display it to the user. Let's get started. First, we need to install MongoDB Community Server from their official website. Select the complete installation. Once the installation is completed, we can open MongoDB Compass. Compass is a easy-to-use graphical user interface of MongoDB. We will come back to this later. Before that, we need to set up few more things. First, we need to add the MongoDB installation folder to environment path variable, so that we can run MongoDB commands from anywhere, in the terminal. Next, we need to create a folder named DB inside data folder in C drive. This is the default path where MongoDB will be creating database and storing data. It is also possible to change this DB path if required. Let's test whether MongoDB is correctly installed and working. Type Mongo version in CMD. We can see the installed MongoDB version displayed. Now let's run the MongoDB daemon by typing mongod. The MongoDB daemon started running. We can either run daemon in CMD or in VS Code terminal. Daemon is the primary process for MongoDB system. When it starts running, it manages everything and handles client requests coming to the database. The client request can be made from CMD by running Mongo command, or using MongoDB Compass, or using our web application. For setting up data, we will use MongoDB Compass. And for fetching and displaying data in UI, we will use Express server of our web application. Let's implement database to our project. Before we jump in, let's understand some basic terminologies. In MongoDB database, a table is called collection, and a row in a table is called document. Open MongoDB Compass. From here, we will connect to the MongoDB daemon. By default, daemon will be running on port 27017 of localhost. So we need to provide the connection string like this. We are successfully connected to MongoDB. Here we can see all the MongoDB databases. To create a new database for our web application, click on the Create Database button at the bottom. We will name the database Market, and we will name the collection Deals. The collection Deals is empty. We can either insert documents manually, or we can import documents from a file. Let's add data from file. For that, we will create a new folder MarketDB, and a JSON file in it. In this file, we need to write an array, containing all the documents to be inserted to the collection. If we look at the expected response, we can see that image name and title attributes are duplicated, and column and row attributes are varying. Hence, we can design the collection like this. Since JSON file do not support single quotes, we will replace it with double quotes. Also, all the JSON keys must be enclosed within double quotes. Let's insert these objects into our collection. We can see 4 documents inserted into our collection. It is currently displayed as a list. We can also view it as objects, or in tabular form. You can also see that MongoDB automatically added unique IDs to all the inserted documents. Data is set up at DB side. Now we need to fetch the data from MongoDB to Express microservice. We will comment out this code. And we will call a function here to fetch the data from database. For that, let's create a database abstraction layer. We will create the file in JavaScript folder. Since we are going to connect to MongoDB, we must first install it using npm. We will then import it in our file. Using the connect method of Mongo client class, we can establish a connection to the database. We must pass the connection string parameter to it. Also, we must set unified topology to true. The connect method returns a promise. Hence we need to chain it with then and catch. In case the connection was successful, we will set a variable to true. Also, we will assign our collection to a global variable db. Now we will write a function query deals collection, which will be called from the deals router file. If the connection was successful, we will process the data, else we will return null. This is the JSON structure we need to return. Let's fetch the handset cards and web cards contents from the deals collection. The find method without any arguments will return all the contents of the collection. The result will be in the form of cursor, hence we will call the toArray method to convert it into an array. Let's store the resulting array into a variable deals collection array. One thing to note here is that the find method will asynchronously fetch the data from database. Hence we need to wait for the result to continue further. For that, we will use the await keyword. And, whenever we use the await keyword, we must mark the function as asynchronous, using the keyword async. Now the only thing remaining in this function is to loop the array and copy the required values. We will create objects for handset and web, and push them to the final JSON response object. For handset, we will copy values only from handset rows and handset cols. Likewise, for web, we will copy values from web rows and web cols. The function is complete. In order to make this function available in other files, we will export this function. Now, in the deals router file, we will import the database abstraction layer. And finally we will call the query deals collection function here. Since it is an asynchronous function, we shall use the then and catch methods. In case of successful response, we will send it to UI in JSON format. In case of error, we will send an empty object. Also, for the UI to understand that this is an error, we will set the status of response to 500, which implies an internal server error has occurred. These are some of the common status codes returned by microservices. Let's run the app and see. Here we can see that the connection to database was successful. There is something wrong with my code. The web cards array contains empty objects. Let's check the DB abstraction layer. Can you see the error? Here it is. Now, on load of UI, we can see that the data is loaded correctly. Let's make a change in database and see. UI, microservice, and database are all now interconnected. See you next time.